Hello, we are Group Mike, presenting our project Navigating Evolving Music.
We were commissioned by composer Ewan Campbell to develop an application to facilitate the performance of a non-linear piece, where the progression of the music over time is not predefined. This piece in particular would use the evolution of the music to portray the evolution of life, complete with mass extinction events.
The result we have achieved is a live interface in which players can choose how to progress within an evolving tree of musical options, and the evolution algorithm, in turn, is influenced by the decisions that different players make.
Here is a walkthrough of the app's interface. The leader of the performance configures settings for the performance, then creates an online room which all of the performers can join via a pin. When all of the players have readied up, the leader can start the performance.
Each performer is presented with their current fragment and a choice of what to play next. They can make a selection via foot pedals or a touchscreen, and if they don't like any of the options, they can choose not to select one at all and instead generate a new pair of choices.
If a performer has their hands too full to select, they can turn on auto-selection, which chooses options at random. And if a performer is struggling to keep up altogether, they can press the self-extinction button, returning to the initial empty rhythm.
The application was intended for cross-platform use, primarily on tablets, so web app was the logical choice. The front end was developed in TypeScript with React and Vite. The back end was written in Python, and we used socket.io libraries over WebSockets for two-way communication between the server and all of the clients.
We decided to come up with a genetic algorithm for the evolution of short sections of music, which we called fragments. We modeled the rhythm, pitch, and accents as a Markov chain for each individual beat, so that it changes one beat at a time. Afterwards, we applied a fitness function to filter bad fragments and present two of the best choices to the players.
Each fragment was split into 5 crotchet beats, each containing a 12-bit array for rhythm, pitch, and accents. Pitch and accents only matter if we're actually striking the instrument. That is, if the rhythm bit is 1. Otherwise, the pitch and accent information is silent, acting like a recessive gene.
We needed a way to accurately synchronize events between the server and clients, so that the visual cue and click track would be aligned across all of the devices. Broadcasting every event from the server as it happened would be subject to variable network latency. Instead, we send timestamps of upcoming events to clients ahead of time and use a clock synchronization algorithm similar to the network time protocol.
The delay between the visual cue and the click track could also vary depending on the audio device. To overcome this, we allowed the user to set the audio latency and separate timeout event fires, taking this delay into account.
The signals that foot pedals send vary, so we needed a way to map those signals to the left and right options that the user can choose from. Therefore, we added a configuration routine to capture those signals.
We'll end with some footage of the app in action in a test performance.